So we're looking at reaction rates. First thing is remember stoichiometry. So here I have, and don't worry about this, you'll have a chance to write it down later. Here I have a balanced equation. We've got ethane reacting with oxygen, forming carbon dioxide and water. And these are all gases, but you could talk about pressure of the gases. But you could also talk about them in terms of molarity, with moles per liter, as long as you have moles and a volume. So this is a unit that you're going to see a lot with reaction rates. But my reminder is this. So just use stoichiometry to relate rates at which reactants are consumed and the rates that products are formed. So if we look at the rates of these reactions, the rates of change for reactants are always going to be negative because they're being consumed, and the rates for products are going to be positive. So we have a question here. Ethane is burned at a rate of 0.2 moles per liter per second. So you'll see it written like this, moles per liter, and you'll also see it written as molarity per second. It's the same thing. What is the rate of CO2 and H2O formation? So the rate for C2H6 for ethane, the rate is negative, right? It's going to be decreasing because it's being consumed. But over here I just made it positive, and we have moles in the numerator, and now we're converting to moles of CO2. So we have a coefficient of 2. That goes here, 4 goes here, and okay, 0.4 moles per liter per second for CO2. And for the H2O, we've got 0.2, 2 going to 6, 0.6 moles per liter per second. So you can also figure out how much oxygen is consumed. This is for a case when you are given the rate of a reactant or the rate of a product. This could also be just in terms of moles, and they might leave the volume out. But if they give you one thing, if they give you information about one, you remember the coefficients, right? Stoichiometry.